In this video we're looking at 2021 paper 2 question 3 and its coordinate geometry of the circle. We're given a circle with centre C and there's a chord AB. We know that the midpoint of the chord is the point D and it's 3, 2. They've drawn a line from C to D and we're asked to work out the radius of this circle. We have to consider something that we've studied in geometry. You have to remember that if you draw a line from the center of a circle to a chord, if it goes through the midpoint, then it's perpendicular to the line. You might have guessed that without even knowing it, but because D is the midpoint of AB, if you draw a line from the center of the circle to the midpoint of the chord, then the lines must be perpendicular to each other. That's the key to how we're going to solve this question. The way that we're going to find the radius is that we're going to look at the right angle triangle ADC. Obviously, an example of a radius is when I go from C to A. So that's the distance that I'm trying to find. We've been told that D is the midpoint of the chord. We're also told that the distance from A to B is 4 root 3. If A to B is 4 root 3, then obviously half of that distance is 2 root 3. Now you'll notice that I've already done a little bit of work here, because the other thing I want to work out is the distance from D to C. Then I'll have two sides in the right angle triangle. I can just use Pythagoras theorem to find that radius. So let's just write in the coordinates there again. All I did here was I labeled D as x1, y1 and C as x2, y2, subbed into the distance formula, and I work out that the distance from C to D is simply the square root of 20. So if C to D is root 20 and D to A is 2 root 3, I can use Pythagoras theorem and I'll find the hypotenuse, or in other words, the radius of the circle. It's very straightforward here. If we use Pythagoras theorem, it's 2 root 3 squared plus root 20 squared will be equal to the radius of our circle squared, where the radius refers to AC. Now if you plug the left hand side into your calculator, 2 root 3 squared plus root 20 squared gives me 32. So I end up with the radius squared is equal to 32. Then all I need to do is get the square root of both sides to work out my final answer. The final answer in this case, the square root of 32 is 4 root 2. So the radius is 4 root 2 units. And that's my final answer for part A. Okay, in part B, we're given the equation of two different circles. We're asked to prove that the circles are touching externally. So I've just drawn a sketch of two random circles here, and we're going to discuss how do you prove the two circles touch externally. Circles touching externally, it means something like this. It means that there's a point in common in each circle. There's a point on the edge of each circle where they overlap. In order to prove that this is the case, I want you to think about the distance between the centers and the radii of the circles. If we work out the distance from the center of one circle to the center of the other circle, then it should be equal to the radius of the first circle plus the radius of the second circle. So in order to prove the two circles are touching externally, we need this. You get the distance from center number 1 to center number 2, and it's the same as adding up the two radii. So that's what we're going to do in part B. Obviously it means step 1, we're going to find the center and the radius of each of the given circles in the question. So the first circle we were given was the circle C, in the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. In this case, in order to work out the center, you have to remember that the center is minus g minus f. 2g is the coefficient of x, in this case 4, so I divide by 2 and then change the sign, and that's the x coordinate of the center. Do the same thing with the y coordinate. So the coefficient of y refers to 2 times f. Divide by 2, change the signs, and I end up with the y coordinate is simply 1. So the center of C is minus 2, 1. According to the maths tables, the radius then is the square root of g squared plus f squared minus c, where I've already worked out g is 2, f is minus 1, and c refers to this. So I end up with 2 squared plus minus 1 squared minus 95. And when you plug that into your calculator, the radius works out as 10. Let's do the same thing now for the other circle. S is in a much simpler format. It's in the form x minus h squared plus y minus k squared equals r squared. Where if we change the sign of the minus 7, that's the x coordinate, We change the sign of the minus 13, that's the y coordinate, and then the square root of r squared gives me r, which is the radius. So now we have the centre and the radius of each circle. So now our goal is, we're going to get the distance between the centres, and hopefully it's equal to radius number 1 plus radius number 2. So the centre of the first circle is minus 2, 1. The centre of the second circle is 7, 13. So if I get the distance between the two centres, I end up with 15. And if the circles touch externally, then the distance between the centres should be the same as radius 1 plus radius 2. So obviously I end up with 15. Remember, the two radii were 10 and 5. When I add them together, that's 15 as well. That proves that the circles touch externally. And the other circle was 7, 13 with a radius of 5. You just need to think about, right, so there's an infinite number of answers here and there's loads of ways of doing it. But I want you to just think, like, let's say I took another point. If I take a point down here, if the centre of the circle was down here, it's impossible for me to draw a circle that will touch the circle C externally at this point. It's simply not going to happen. If I have a centre of a circle here, again, it's impossible for a circle to touch this one externally at this point. What I need is, I need another point along the same line. If I draw a point here on the same line as the centres are already on, if this was the centre of a circle, I could draw a circle now that touches the large circle here externally at this point. If I take another point on the line, I could certainly draw a circle that touches externally at that point. The key here is, you have to recognize that there's a line that contains the centre of the first circle, the centre of the second circle, and the point where they touch. Any point on this line is the centre of a circle that satisfies the conditions they're asking for here. So all we need is any point on this line. The only mistake that you might make here is, obviously it can't be a point inside the original circle. If it touches externally, the centre has to be outside the circle. So now I've drawn a load of dots there, so I hope it doesn't confuse the matter, but ultimately this is what we had last time. And I want you to think about this straight line. Any point on that line that's outside the circle C, I could draw a point anywhere and then a circle that touches externally at that point. So I'm probably in a very long-winded way, I'm trying to explain to you that all you need to do is find any point on this line. Now, probably a long-winded way of doing it is, I know this point and I know this point, so I could get the slope of the line, I could get the equation of the line, and then I could find specific points on the line. But what occurred to me is the easiest way to immediately find another point on the line that I'm after drawing is just do a translation. I want to travel from here to here and then go the same distance again. If I just say, how do I go from this point to this point, and then just do the same thing again, essentially I'm going to find another point on the same line, and it'll be on this line, so it's an answer to the question. So the easiest way I think of doing this question is, the centre of the circle C is minus 2, 1. The centre of the other circle is 7, 13. In order to go from C to the centre C to the centre of S, the x value goes from minus 2 to 7, or in other words, it goes up 9. The y value goes from 1 to 13, or in other words, it goes up 12. So if I just do the same thing again, I go up another 9, 7 and 9 gives me 16, 13 plus 12 gives me 25. I immediately can say that this point and the point 16, 25 and this point, they all lie on the same line. Essentially, the way I just did that, I'm after making 7, 13 the midpoint of minus 2, 1 and 16, 15. But it's very easy maths, and you do it in almost 30 seconds there. Now, this answer satisfies the question. If the centre of a circle was 16, 25, I could draw a circle now that's an awful circle, but I could draw a circle that has 16, 25 as a centre and touches the point C externally at the same point as the circle S did. Now, obviously, there's loads of different ways of doing that question. That's just the easiest one that I can see, because it's a very simple arithmetic. probably the way I imagine most students would have done it is find the equation of the line and then find points on the line. Obviously, if you get the equation of this line, you can then just sub in like x equals 8 or x equals 10, or you can sub in different values for x and get the corresponding values for y, and there's an infinite amount of possible answers here.